Hello, welcome back once again. Today we have this JEE Advanced Integral. The integral from 0 to infinity natural log of x divided by x squared minus 5x plus 25 dx. So let us start with the following substitution. We're going to let x equals 25 all over u. Now let us solve for u in terms of x. So you get u is also equal to 25 divided by x, right? Now from this equation right over here, differentiate both sides, we get dx is equal to the right hand side will give us negative 25 all over u squared du, right? So our integral I is going to be equal to the integral. Now let's talk about the limits of integration. Now we know if x is approaching 0, u will approach 25 divided by 0, which is infinity, right? Now when x is approaching infinity, u will approach 25 divided by infinity, which is approaching 0, right? Now the natural log of x will become the natural log of 25 all over u. Then divided by x squared is going to be 25 all over u whole squared. Then minus 5x will be minus 5 into bracket 25 over u. And then plus 25. Our dx here is going to be negative 25 all over u squared. And then we have du. Okay, so from here, our I is equal to, now if we switch the limit from 0 to infinity, then the negative sign at the du will get cancelled, right? So from here now we have the natural log of 25 all over u divided by, so here this is 625 all over u squared, right? Because 25 squared is giving us 625. So here we have 625 all over u squared. So here this is going to be negative 5 times 25 is giving us 125, then divided by u. Don't forget that. Then plus we have 25. Okay, so here don't forget we have 25 divided by u squared, and then we have our du. This is really cool. So what is next? We're going to open the bracket at the denominator using u squared, right? So from here, this is going to be equal to, don't forget, we have something really cool. This is 25 multiplied by the integral from 0 to infinity. Then natural log of 25 all over u divided by u squared is going to open the bracket 625 over u squared minus 125 all over u plus 25. Then du. Okay, so from here we have I is equal to, this is 25 multiplied by the integral from 0 to infinity. Then up here we have the natural log of 25 all over u, then divided by, now u squared times 625 over u squared is giving us just 625, minus u squared times 125 over u is giving us 125 u, and then plus u squared times 25 is giving us 25 u squared, and then we have our du. So what are we going to do from here? So we're going to factor out the common, and I hope you know that, and that's going to be 25, right? So here from the denominator, the 25 is common, so we're going to have 25 integral from 0 to infinity. So here we have the natural log of 25 over u divided by, factor out 25, and everything will turn out to be u squared minus 5u plus 25, and then du. Now we know with the 25 at the denominator, these both get cancelled, right? Therefore our I will be equal to the integral from 0 to infinity the natural log of 25 all over u, then divided by, this is u squared, minus 5u plus 25. With the property of logarithm, the numerator is going to become the natural log of 25 minus the natural log of u, then divided by u squared minus 5u plus 25, and then du. Now we're going to split the denominator, and we're going to replace u with x, since u is just a dummy variable, okay? So I is going to be equal to the integral from 0 to infinity. This is natural log of 25 divided by, this is going to be x squared minus 5x plus 25 dx, and then minus the integral from 0 to infinity, the natural log of x divided by x squared minus 5x, and then plus 25, and then we have our dx. But don't forget that this right over here is I, right? And that is exactly the integral we started with, right? Which is exactly I. Therefore, this integral I is equal to the integral from 0 to infinity, the natural log of 25 divided by x squared minus 5x plus 25 dx minus I. Now, if you add I to both sides, we get 2I is equal to the integral from 0 to infinity, the natural log of 25 divided by x squared minus 5x plus 25, and then we have our dx. Now we can kindly divide both sides by 2, and therefore we have I is equal to, this is 1 over 2, the integral from 0 to infinity, the natural log of 25 divided by x squared minus 5x plus 25 dx, which is same as, remember, the natural log of 25 is equal to the natural log of 5 squared, which is 2 ln of 5. Then 1 over 2 times 2 ln of 5 is given us just the ln of 5. Multiply by the integral from 0 to infinity, then we have 1 divided by x squared minus 5x plus 25, and then dx. Okay, so what are we going to do from here? We're actually going to complete the square of the denominator. Okay, so let's see how we're going to do that. So x squared minus 5x plus 25 is going to be equal to, x is squared here, right? Then we're going to have minus 2 multiplied by the x, which is squared, multiplied by, we're going to multiply by 5 all over 2. Then we're going to add the square of 5 all over 2, right? So if you add the square of 5 all over 2, to complete that 25, we're going to have to add 75 all over 4. Now let's see. So this is equal to x squared minus 2 multiplied by x multiplied by 5 all over 2. Then plus here, this is 25 over 4, and then plus 75 over 4. So you can see, if you add this up, it is equal to 25, because it will give you 100 all over 4, which is this 25 right over here. And here, if you multiply through to get cancelled, you have negative 5x. So you can see that nothing absolutely changed. Okay, so we know this algebraic property that a minus b whole squared is equal to a squared minus 2 times a times b, and then plus b squared. So if you take a look, our a here is equal to x, while our b is equal to 5 all over 2, right? So with this help, or this idea, I mean, x squared minus 5x plus 25 is going to be equal to, x minus 5 by 2 whole squared, and then plus 75 all over 4. Therefore, our I is going to be equal to the ln of 5 integral from 0 to infinity. So we're going to have 1 divided by, so this is going to be x minus 5 all over 2 whole squared plus 75 all over 4, and then we have our dx. So I think from here we're going to make the following substitution. We're going to let x minus 5 over 2 equals t, right? So differentiate both sides, dx is actually equal to dt. So therefore our I in terms of t is going to be the ln of 5 multiplied by the integral. Now if x is approaching 0, t will be approaching 0 minus 5 all over 2. Is that 5 all over 2? Yes, but I think we need to do something. Oh, sorry for that. So let's do something more elegant, okay? So we can actually simplify the denominator further, right? So this is going to be ln of 5, the integral from 0 to infinity. So 1 divided by, so this is same as 2x minus 5, right? Divided by 2 whole squared, and then plus 75 all over 4 dx. So simplifying further again, this is equal to the ln of 5, the integral from 0 to infinity. So this is 1 divided by, so if you square 2x minus 5 squared all over 2 squared is 4, and then plus 75 all over 4, right? And then dx. So we know the 4, we can factor it out, and it's going to be 1 divided by 1 over 4, which is 4. So we have 4 ln of 5 multiplied by the integral from 0 to infinity. So we have 1 divided by, so this is 2x minus 5 whole squared plus 75 all over 4, and then dx. So now we can make, oh, that is 74 actually. Sorry for that, okay? So this is 75. Now let us go ahead and make our substitution. So we're going to let 2x minus 5 equals t. So 2 dx is equal to dt. So from here, divide both sides by 2, we see that dx is actually equal to dt all over 2. So therefore, our I is going to be equal to 4 ln of 5, the integral. Now, if x is approaching 0, t will approach 2 times 0 minus 5, which is giving us negative 5. When x is approaching infinity, t is absolutely approaching infinity, okay? So here, this is 1 all over, this will be t squared plus 75. Our dx is equal to the t all over 2. Take the 1 over 2 outside, we just have 2 ln of 5 multiplied by integral from negative 5 to infinity, 1 all over, this is t squared plus 75, and then dt. So from here, I is equal to 2 ln of 5 multiplied by integral from negative 5 to infinity. This is 1 divided by, this is t squared plus 75. You can write it as a square of number, which is root of 75 whole squared, and then dt. Then we recall this standard integral formula. So the integral of 1 all over x squared plus a squared dx is equal to 1 over a multiplied by the inverse tangent of x over a, then plus c. So use that identity there. So I is equal to 2 ln of 5, then multiply by 1 all over root of 75 multiplied by the inverse tangent of t all over square root of 75. Then our limit from from negative 5. So our limit from negative 5 to positive infinity. And we know root of 75 is my root of 25 times 3, which simplifies to 5 root 3, right? So I is equal to 2 ln of 5. So multiply by 1 over 5 root of 3. Multiply by the inverse tangent of t all over 5 root of 3, with our limit running from, that's negative 5. Don't know what is wrong with me today. So this is actually negative 5. So I is equal to, this will be 2 ln of 5 all over 5 root of 3. Then multiply by now. Put the upper limit to get the inverse tangent of infinity. Minus the lower limit to get the inverse tangent of, we know that is going to be negative 1 over root 3, right? Okay, so from here, I is equal to 2 ln of 5 divided by 5 root of 3. Then in the bracket, inverse tangent of infinity is pi by 2. Now, inverse tangent of negative 1 by root 3 is equal to negative pi all over 6. With the negative sign, it becomes plus pi all over 6. So this is equal to 2 ln of 5 all over 5 roots of 3. Then multiply by, so pi over 2 plus pi all over 6 is giving us 2 pi all over 3. Right? So simplifying properly, we now get, that is going to give us finally 4 pi multiply by the ln of 5, then divided by, this is 15 root of 3. So this is our correct answer, which is approximately 0.778452656663. So this right over here is our solution. Thank you for watching. Please, if you really enjoyed this video, kindly subscribe to this channel. Also like, comment, and share.